Good afternoon to all. Today we are going to start with the topic named as distributed computing, utility computing, and introduction to cloud computing. Now this is the introduction to distributed computing. Distributed computing means there is a one central node and multiple workstations or different nodes are located at a different places. It means all the nodes that is connected with server is not at a same location. They are at a different locations. So in case of distributed computing, we follow decentralized architecture. It does not follow centralized architecture. It follows decentralized architecture because multiple nodes are on a different locations. So distributed computing does not mean that they are at a different location so that they can't communicate with each other, they can't share the resources. All the nodes that are connected with the distributed computing, they are able to communicate with each other, they are able to access the resources. So distributed computing is one of the computing where we can do the work or where we can connect it with the central server, but the nodes that are connected with the server is at a different locations. They are not at a same location. This is the diagram of distributed computing. See, in this diagram, multiple workstations or nodes are connected. It may be a laptop, it may be a mobile phone, it may be a computer, it may be a server. And this central server is connected with web server for web services, and again it is connected with a database server for database connectivity. So see, this is the way how the distributed computing work on. So distributed computing means we have a one central server and multiple nodes or multiple workstations are connected with it. Next, we have a benefits of distributed computing. First one is scalability. It means we can add or we can increase the number of nodes that is connected with centralized server. Second is redundancy. It means high availability. If one node, if one workstation get fail and get down, we don't need to stop the work. We can switch to next node immediately. So it is first one, it is scalable computing because in this we can increase or decrease the number of nodes or workstation according to the requirement. And second is that if any node have any type of problem, we don't need to wait, we don't need to stop the work. We simply need to switch to the next node. So these are some of the advantages of using distributed computing. In this case, if we want to go for a distributed computing, we just need to purchase the hardware from the vendor, from the seller, and all the hardwares are independent of each other. Some hardware follow Linux operating system, some hardware follows Windows, some follow the Mac operating system. So for distributed computing, we just need to run a hardware and that hardware should be provided by a vendor. So there are lots of vendor in the market from where we can buy or get the hardware. These are some of the examples of using distributed systems or application area where we can use distributed computing. We can use it in intranet or internet or in World Wide Web and email. We can also use distributed computing in telephone network and cellular networks. Next, it is used in information systems for handling the automatic processing of orders. If we want to do the ordering system in an automatic manner, we will use distributed system. It's also used in aircraft control, electronic banking. Even we can use it in an airline reservation system, sensors network, or it is used in a mobile computing system. So these are some of the applications where we can use distributed computing. As we know that for distributed computing, we have to run the, so in distributed computing, we need to run the hardware and we can buy this hardware from any vendor. and the hardware is a platform independent. Some hardware depend upon Linux operating system, some follow Unix operating system, while others have a Mac operating systems. So we have some characteristics of distributed system. First one is concurrency of components. Next is lack of global clock. And the third is independent failure of components. It means concurrency is the problem when two or more processes requesting for a same resources. Next is lack of global clock. Concurrency is one of the problem where two or more than one processes are waiting for the same resources. So in distributed computing, no all the components are on the same location, so there will be less chances of concurrency. It does not have a global clock. And third is that independent failure of component, as all nodes are not on the same location. So if any problem arises to any node, it does not affect to the other node, because let us suppose one node is in a Amritsar, one node is in a Jalandhar. So if any problem occur to the Jalandhar node, it does not affect the working of Amritsar node. So this is called independent failure of components. As we have already discussed, these are the application area of distributed computing. We can use it in internet, banking, airline reservation, mobile phones. We can use it everywhere. Next is the architecture of distributed computing. We have client server architecture. We have a 3-tier architecture. We have an n-tier architecture, or we have a peer-to-peer architecture. In client server architecture, we know that we have one client and one server. Both can communicate with each other directly. Second is 3-tier. It means in this we have one more tier. One is client, second is server. It means there is a one more tier. That is called middle tier. So first we have a client. Client send the request. It goes to the middle tier. From middle tier, it goes to the server. Then server process the request. In the same way, when server process the request, server generate the result. Result is not directly sent to the client from server. First, it goes to the middle tier. From middle tier, it goes to the client. So there is one middle tier. Next is n tier. N tier means we have number of tiers. It may be 2 or more clients. We have 2 or more servers, or it means we don't have any limit on the number of tiers. Next is peer-to-peer. It means in this case, or in this architecture, no special machines provide a service or manage the network resources. There is one server or one computer that serve as both client and server. That's why it is called peer-to-peer. We have only one machine, and that machine at the same time working as a client or working as a server. Examples of this include BitTorrent and Bitcoin network. Next type of computing we have is called a utility computing. Utility computing is one of the computing that we get on the demand. How much cloud space you want to use on the internet, you have to pay accordingly. If you want to purchase some more space or big space, you have to pay more money. If you want to purchase a less space or a short space, you have to pay the less money. So utility computing means I want to do the computing on the cloud, means on the internet, and what I have to pay, it's completely depend upon my uses. For example, Google and Amazon's are one of the well-established or well-known organizations that have their own utility computing. So in utility computing, I just need to pay the money to the vendor to get the space or to get the cloud over the internet and do my work. The money or the cost is depend upon your uses. If you use it for if you want to purchase a large space, you have to pay more money. If you want to purchase a small space, you have to pay the less money. This is the image of utility computing. We have new, then bespoke, then products, and we have different services, like we have a software service, we have a framework service, and we have a hardware service. These are some of the examples of using the utility services or utility computing. First, CPU time. We can pay the money to the vendor to get the CPU time. We can purchase the hardware, hard drive space or its access time. Even we can purchase the virtual and physical memory. We can purchase the network bandwidth, environment variables, and storage space. These are the applications area where we can use utility computing. These are some of the advantages of utility computing. Let us suppose I want to implement the utility computing. I does not need to buy my own software. Let us suppose I want to use it for 1 month. I have to pay to the vendor for 1 month. After 1 month, it got expired. It means I do not need to spend or waste my money on buying it for a lifetime. I will buy it according to my requirement. If I need it for 10 days, I have to pay accordingly. If I want to buy it for 20 days, I have to pay accordingly. It has some disadvantages. First one is reliability. As I have already told to all of you, we have to pay the money to the vendor and get the cloud or space over the internet. But if the vendor have financial issues, his or her company get financially down, then you have to bear the loss also. Second is that it can be targeted by hackers because it is designed by third party, it is sold by third party. So how can we make it sure that it should be completely secure? So there is a more chances of hacking. Next topic is introduction to cloud computing. In this, we have to study visions of cloud computing, defining the cloud delivery model, cloud deployment model, characteristics of cloud, benefits of cloud, challenges means what the problems we have to face if we are going for a cloud computing, then difference between a cloud, cluster, and grid computing. Now start with the introduction. Let us suppose that I'm owner of an organization. I have lots of employees working in my organization, and it's my responsibility to make it sure that all employees have a right hardware, software, or good working computer. So there is one scenario where the number of employees are increasing. It means I have to spend more money on buying the hardware and software and other peripherals for every employee. So it's a waste of money. I have to handle it. The solution is cloud computing. Instead of giving the right hardware and software to every employee of my company, I will purchase cloud. I will start cloud services where multiple employees of my organization can get the access very easily. This is the cloud computing, client computer. In this area, first we have a computer network. It is computer network means we have more than one nodes. We have a database storage, application server, then we have a control node. All these components are connected directly with the client computer to implement cloud computing. Now, if we are going to implement cloud computing, we don't need to put more focus on the local computer. Once I have purchased the cloud over the internet, my everything should be connected with the cloud computing. I don't need to put or waste more money on purchasing the hardware, on purchasing the software, or on purchasing the server. Everything is now on my cloud. This is the introduction of cloud computing. We all know that cloud computing means we get the space, we get the cloud over the internet where we can do everything. We can store the data, we can do networking, we can do intelligence or multiple tasks we have to do over there. So cloud computing means we have to pay the money to the vendor, get the space or get the cloud over internet. When you go for a cloud computing, you don't need to put more stress or focus on your physical setup of your computers, like on a hardware, on a software, or on any other accessory or peripherals of computer system. Next, we have a cloud delivery model. Three types of models we have: IaaS, PaaS, or SaaS. IaaS means infrastructure as a service. PaaS means platform as a service. SaaS means software as a service. So some provide infrastructure as a service, some companies provide platform as a service, or some provide software as a service. This is called cloud delivery model. SaaS, PaaS, IaaS. This is infrastructure as a service, and it's also known as a hardware as a service, HaaS. It give you infrastructure as a service. When you want to go for cloud computing, you don't need to purchase your own physical servers. When you pay for cloud computing, you get the complete infrastructure over the internet also. It has some characteristics. In this, resources are available as a service. All the services are highly scalable and they are dynamic, they are flexible, and it is based on GUI, graphical user interface, and application programming interface access. And in this, all the administrative tasks are automated. So infrastructure as a service means some of the companies, some of the organizations provide you infrastructure as their service. They are giving infrastructure to all of you. It means when you get infrastructure, you don't need to put the money, or you don't need to spend the money to purchasing or buying the physical servers. These are the some of the examples: DigitalOcean, Linode, Amazon Web Service, Microsoft Azure, Google Compute Engine, Rackspace, and Cisco Meta Cloud. It means all these organizations and companies providing their service as a infrastructure. This is the diagram of infrastructure as a service. This is the software owner. It means this is the vendor to whom this end user will pay the money and get infrastructure as a service. End user have a firewalls. Firewalls is there because firewall protect your network from outside attack. Then we have a load balancer for balancing the loads of every node. We have a compute power. Now software owner have a virtual machine. Then virtual machine is uploaded into storage media, and after that we will done the virtual machine automation. Then virtual machine is deployed and start. Once it is automated, it start its working. Then it has a compute power. So this is the diagram of infrastructure as a service. Infrastructure as a service means the vendor provide its services as an infrastructure. He or she is selling the infrastructure as their service. These are the examples of the organizations or companies that are providing IaaS. Amazon Web Services, NetMagic, Rackspace, Reliance, CFeed, Data Communications. It has some services. It provides computing service for computing. You have a virtual machines. Then storage, it provides you a very good storage space for storing your files. It also provides you a networking components like routers, like switches, like bridges. And it has load balancing capacity at their infrastructure layer. These are the services: compute, storage, network, load balancers. Characteristics, same like applications or this. Advantages: shared infrastructure. It allows multiple users to share the same physical infrastructure. In this, sharing is possible. It provides its user to access the resources over internet. Next, pay as per use model. You have to pay according to your use. If you are using cloud for a long time, you have to pay more. If you are using cloud for a short time, you have to pay less. Focus on core business. It does not focus on infrastructure, it focus on organization core business. On-demand scalability. This is one of the advantages. You can upgrade it or you can scale it according to your requirement. You can increase the number of nodes or even you can decrease the number of nodes. Some disadvantages of IaaS: security. It does not ensure 100% security. There is a chances of lack of security. Next is maintenance and upgrade. Sometimes it's tough to maintain it or update it. It will create a problem. Interoperability issues. It means if you want to migrate your services from one virtual machine to some other virtual machine, it will create a problem. Its migration is not so much easiest. Next, we have platform as a service. Basically, platform as a service means some of the companies in the country, some of the organizations in the world that is providing platform as their service. They are giving you an environment, they are giving you a platform where any programmer can run, can execute, or can test their applications. So basically, platform as a service provide you a runtime environment where all the programmers can develop their application, test their application, run their application, and manage their application. Basically, platform as a service means some of the organization giving their service of platform. It has some characteristics. One is it is accessible to multiple users via same development application. It means multiple users can use a same application environment. It is also connected, it also attach its application with the services and with databases. So we have application, web server, and database. All three are connected with each other. It follow the virtualization. It introduced the concept of virtualization. It support multiple languages and frameworks. So it support multiple languages and their framework. It has the ability to auto scale. According to the requirement, the number of nodes increased and decreased automatically. Its example are AWS Elastic, Beanstalk, Windows Azure, Heroku, Force.com, Google App Engine, Apache Struts, Magento Commerce, Cloud and OpenShift, and Force.com, Google App Engine, Azure. These are the organizations that are supporting platform as a service. This is the example. Developer give you an integrated development environment. With this environment, developer ensure the data security, backup and recovery, application hosting, and scalable infrastructure. Then it design a business app that is used by a business user. So basically, it gives you a platform to design your applications where you can write your application, test your application, and manage your application. Some of the services: programming language, application frameworks, databases, and other tools. It provides you a different programming language for designing your application, like Java, PHP, Ruby, Perl, and Go. It provides different application platforms or frameworks like Node.js, Drupal, Joomla, WordPress, Spring, Play, Rack, and Gent. Application frameworks where we can design the applications. Then it provides database like ClearDB, PostgreSQL, MongoDB, and Redis to communicate with the application. Then it provides some other tools that are used to develop, test, and deploy the applications. These are some of the services. Popular PaaS providers: Google App Engine, Windows Azure, AppFog, OpenShift, Cloud Foundry from VMware. These are the companies and organizations that are providing PaaS as a service. Some advantages: simplified development. Its development is very easiest, so it will not take us so much time. Second is low risk. The chances of risk is less as compared to other services. Pre-built business functionality. It supports some inbuilt business functionalities. You can use all these business functionality directly. Instant community. It provides online communities where developers can get idea to share an experience and seek advice from others. It means it works on the community level. Multiple people are connected in this, so where they can talk with each other or get idea from each other. Next, we have scalability. Scalability means we can upgrade it or change it according to the requirement. Some disadvantages: vendor lock-in. Vendor lock-in means if your service is run on a one virtual machine, it is very difficult to migrate it into some other virtual machine. Next, data privacy. This is one of the greatest problem, because we pay the money to the third person It is designed by third person. It is sold by third person. So there are more chances of data hack. Next is integration with the rest of system applications. If you want to attach your local applications with your cloud, it will create a problem. Even it will create some type of difficulty. So these are some of the disadvantages. Next, we have a software as a service, SaaS. It's also known as on-demand software. Basically, in this, you have to pay the money to the third person to get software as your service. We pay to the vendor or we pay to the third person, then we get the softwares as a service. Services provided by software as a service. It provides business services like ERP service, CRM, customer relationship management, billing, and sales. Next, it provides some document management. SAS document management is the software application which is provided by third party to create a document, to manage a document, to track some electronic documents. Next, we have social networking. This is one of the service that is provided by software as a service. For example, we have a Facebook, Instagram. These are the services that is provided by software as a service. Next, we have mail services. Mail services like we can write down the mails, we can compose a mail, we can send the mail, we can receive the mail. It means we can send the mail to the multiple users on a same time. So these are some of the services that are provided by software as a service. These are the services: business, document, social networking, and mail services. Advantages: no special hardware or software version is required. You just need to pay the money to the vendor and you start working on the cloud. You don't need to pay your own software, own hardware, nothing you need to pay. Multi-device support. It means you can access the cloud from desktop, from laptop, from tablets, from phones, or from thin clients. Next is API integration. So it means it can easily integrate with other software through some APIs, application programming interface. No client-side installations. When I pay the money to the vendor, I get the access to the cloud directly. I don't need to install any software on my own computer. Popular providers: Microsoft Office 365, Google App, GoToMeeting, Constant Contact, Oracle CRM, NetSuite, Workday, Salesforce.com. These are the popular organizations that are providing software as a service. Disadvantage: again, security. Security will be the main problem because we are purchasing it from a third party. We don't know how they does the coding, how they do the working. So there is a more chances of lack of security. It's completely depend upon internet. Without internet connection, it is zero. It only works when you have a stable internet connection. Switching between software as a service vendor is difficult. If you want to switch means if you want to migrate your software from one virtual machine to some other virtual machine, it will create a problem. Next topic is deployment model. In this, we have 4 types of models: public cloud, private cloud, hybrid cloud, and community cloud. Public cloud means that cloud, that space is visible to everyone because it's a public. So anyone can access it. So it is basically controlled by third party. Third party means cloud service provider. You have to pay the money to the service provider and get the cloud over the internet. And it's public so that it can be used by multiple people at the same time. It may be on managed or operated by maybe a businessman or maybe a universities, maybe a government organization or combination of both. Its examples are Amazon Elastic Compute Cloud, Microsoft Azure, IBM Blue Cloud, Sun Cloud, Google Cloud are the example of public cloud. Public cloud means this cloud is available to everyone on the internet. Anyone can pay the money to the cloud service provider and get that cloud. So multiple users can access that cloud at a time because it's publicly available to everyone. Its providers are IBM, Amazon, VMware, and Google. Some advantages, it's low cost, it's public, so it's available to everyone, so it is not so expensive. Second, location independent, because its services are provided through internet, so we can sit on anywhere or access it from anywhere. So it's a location independent. Save time. Public cloud helps to save a time because in this case, every task should be done by the service provider. User only need to use it. Next is business agility. It means it is used to handle your business according to your requirement. It means you can even, it should be scalable. You can even increase the number of nodes or the workstations, or either you can decrease according to your requirement. It's a scalable and reliable. It is always be available 24/7, or we can easily add and remove any number of users to this cloud at a very cheap cost. Again, security will be the main problem because it is handled or managed by third people. Performance means its performance is completely depend upon the speed of internet connectivity. If you have a good speed connection, it will give you a good performance. If you have a low speed connection, it will create a problem. Less customizable, it means it is not so customizable. It is less than as compared to private cloud. See the private cloud. Now its name reflects it's private. It means it is not available to public. It is not available publicly to everyone. It is only available or given to some selected people. So as compared to public cloud, it is private. It is available only to some selected people. That's why it has the high level of security. For security, we can use the internal hosting or we can use some type of firewalls. Its examples are HP data centers, Microsoft, Ubuntu are the examples of private cloud. It may be handled by one organization and there is one chances of security because it's private. It is not available to anyone. It is available only to some selected people. Advantage is more control because it is not publicly available to multiple users. They are available to selected people, so it's easy to control. Second, security and privacy. Yes, it is more secure as compared to public because we can trace the number of users who are using it because it's not available to multiple persons. Improved performance. It gives good performance, good speed, good space as compared to public. Disadvantages, high cost. Yes, it is giving you a high performance, high data security. That's why it's so costly. Restricted area of operations. It has restricted area of operation. It is not do the operation in an open manner because it is only given to the selected people. So they have some restrictions. Third is limited scalability. It is limited to its scalability. We cannot increase or decrease it accordingly. And last is skilled people. We need some specialists, some trained, some experienced and skilled people to handle the private cloud. Hybrid, combination of both. Hybrid cloud is the combination of both public and private. Basically, it is used to provide a well-managed, automated and unified computing environment. Public is used for non-critical activities. Private is used for critical activities. Basically, hybrid is used in a finance, in a healthcare or in a universities. Examples are Amazon, Microsoft, Google, Cisco and NetApp. They are supporting hybrid cloud, means combination of public and private cloud. See in the image, hybrid cloud is the combination of both public and private cloud. Some advantages. First one is flexible and secure. Yes, it's more flexible and secure because it follow both clouds, public and private. Second, cost effective. Again, it is supporting both clouds. public and private, that's why they are costly. Next is security. Security means it is more secure because in this case public is for non-critical applications and private is for critical applications. Fifth is risk management. We can manage the risk in a very easiest way by using a hybrid. So it's flexible and secure, cost effective, it gives good security, and in this case it's possible to manage the risk. We have some disadvantages of using hybrid cloud. First is networking issue. Sometimes networking become very complex problem or very high issue in case of hybrid because we are following both public and private. Next is infrastructure compatibility. Major issue in this. With dual level of infrastructure, private cloud control the company and public cloud does not. So there is a possibility that they are running in a separate stacks. Reliability, its reliability is completely depend upon cloud service provider. If cloud service provider is from a good quality and they are from a big organization or a well-known organization, then it should be reliable. Last, we have a community cloud. Community means it is supported by more than one organizations. It's clear from its name, community, supported by more than one organization. So this type of cloud is owned, managed and operated by more than one organization and the community, that is by third party or combination of them. Community are cloud organization 1, organization 2 and organization 3. It's a community group of more than one organization. Advantages are, first one is cost effective. As it is supported by multiple communities, so they have to pay more for this. It's flexible and scalable. We can easily use it and modify it according to the requirement. Its security is also a very good thing because it's secure as compared to public, but it is less secure as compared to private. And this, we have a sharing infrastructure. Community cloud can share the cloud resources, infrastructure, capabilities among various organizations. Some disadvantages, it's not a good choice for every organization and it is sometimes it is slower in the adoption of data. Next is fixed amount of data storage and bandwidth is shared among all community members, no matter the members are small or members are large. Community cloud is costly as compared to public cloud and the sharing responsibility among organization is very difficult task in case of community cloud. Now, next topic is challenges ahead. It means when we go for a cloud computing, what the problems we have to face. There will be a chances of security and privacy problem, interoperability problem, portability problem, computing performance problem, or there will be a chances of reliability and availability problem. Now see one by one. First is security and privacy. As we have already discussed, cloud computing means we have to give the money to some vendor and purchase cloud over the internet. So security and privacy will always be the biggest issue because it is controlled, managed and running by the third party. So there will be a chances of lack of data or there will be a chances of data hacking. But it's our responsibility to overcome this problem. We can use the encryption or some other security tools. We can use a secure hardware or secure applications to protect your data from hackers, from attackers. Next is portability. Portability means when I want to migrate my applications from one virtual machine to some other virtual machine, sometime it will create a lot of problem. So I have to solve this problem. This can be done by choosing either you can choose an infrastructure as a service, either you can choose a platform as a service, or you can choose a software as a service, but choose which give you a capability to run on a independent programming environment. And we know that platform as a service is one of the service provider that give you a platform independent where programmer can write down the application into various languages. Interoperability. It means applications that is running on one platform can cooperate with the applications running on the other platform. If they are not comfortable or cooperative with each other, then it's very tough or it's very difficult to share resources among them. Computing performance. Computing performance is always depend upon your network bandwidth or network speed. If you have a good network connection, you will get a good performance. If you have a low network connection or unstable network connection, it will completely hamper or damage the performance of your computing. Next is reliability and availability. This is very important feature, or this is one of the greatest challenge and issue we have to face. Make it sure that it's reliable and available. Reliable means we can add or remove it accordingly, and available means if there is a, if one node get corrupted or get failed, we can immediately switch to the next work without supporting our work. So these are some of the challenges that we have to face when we need to go for or when we implement cloud computing. These are the benefits of cloud computing. Cost. I don't need to pay money on my own computer. Once I pay the money to the vendor, I can do everything on a cloud. It gives a very fast speed because everything is now available on a cloud. Third is scalability. We can increase or decrease the resources, requirement of resources according to the business requirement. Productivity means, in this case, we don't need to put more stress on the hardware and on purchasing the software. Once we pay the money to the vendor, we can get access to the cloud very easily. Next is reliability. Backup and recovery of data is very expensive, so it's a good. Security is also one of the benefit that should be provided by cloud computing. We can use encryption, we can use a secure hardware and software. So these are some of the benefits of using cloud computing. These are the characteristics. On-demand self-services. We can pay to any, like we can pay to software as a service, we can pay to platform as a service, we can pay to infrastructure as a service. So it means we can get the services on the demand. You just need to pay and get the services. Broad network access. Now everything is on our internet. It provides broad access. We can access anything from the internet anywhere. Rapid elasticity. It means when you get the request, it should be capable enough to give the resources at that time. Rapid, fast elasticity. It means whenever the user requirement serve, it is provided to him and it scale out as soon its requirement get over. It means when any customer want to get the services, they are provided to him or her immediately. Resource pooling. Resources are present in the network pool from where the multiple nodes can get the resources according to their requirement. Measured services. It means we can do the monitoring, we can do the administrating so that we can measure the services. It means we keep record of all the services that we are providing. So these are some of the characteristics of using cloud computing. Now, difference between cloud and cluster computing. First category is goal. So cloud computing provide on-demand IT resources and services, whereas cluster computing perform a complex task in a modular approach. So its goal is to provide on-demand resources, and goal of cluster computing is to perform a complex task in a modular or in a manual approach. Resource sharing is not possible in a cloud, because whereas in both cases, in either in a cloud or in a cluster, resource sharing is not possible. Resource type. Heterogeneous types of resources in a cloud means different type of resources. In cluster, as we have no, cluster means homogeneous, similar. That's why resource type is also of homogeneous. Virtualization, hardware and software virtualization is possible. No virtualization of resources in cluster computing. Next is security. Security through isolation can be achieved in a cloud computing. Security through node credentials can be achieved in a cluster computing. It means security is present in both computing, cloud or cluster. Initial cost, its setup cost is low, its setup cost is high. Security requirement in cloud, it's very low, in cluster it's very high. Maintenance, cloud require low maintenance, cluster require little more maintenance as compared to cloud. Hardware, in cloud no hardware required physically because everything is on a cloud, and in cluster hardware required physically. Node operating system, it's for cloud support multiple operating systems that are running in a virtual machine. Cluster support only Windows and Linux. User management, in case of cloud it can be centralized or decentralized. In case of cluster it is centralized only. Scalability allowed in a cloud, whereas in cluster we have a limited scalability. Architecture, the user can choose their own architecture. In cluster oriented architecture you have only. Characteristics, cloud perform dynamic computing, infrastructure, resources and services. In cluster, all the components are tightly coupled. Software dependent, all components are independent in cloud and they are dependent in cluster. Example, Dropbox and Gmail. Example of cluster computing is Sony PlayStation cluster. So this is the comparison or difference between cloud computing and cluster computing. Now see the difference between cluster and grid computing. In cluster, all the nodes are of homogeneous. Homogeneous means same type. Cluster means same, that's why nodes is of a homogeneous nature. In grid, nodes have different operating system, different hardwares. They can follow either a homogeneous or heterogeneous both. In cluster, all computer perform same task. In grid, they can perform different task. In cluster, they are located with each other, and in this, they are not tightly coupled. They have at a long distance or at some distance. In cluster, computers are connected by a high-speed local network bus, and grid computer are connected by using some low-speed bus or a internet. In cluster, computers are connected in centralized network. In grid, they are connected in a decentralized network. In cluster, whole system has centralized resource manager. In grid, every node has its own resource manager. In cluster, whole system function as a single, or in grid, every node is autonomous. They are independent of each other because they are not at a same location. In cluster, scheduling is controlled by central server. In grid, it may have servers, so mostly each node behaves independently. So scheduling is not controlled by server in case of grid computing. This is the difference between cluster, grid, and cloud computing. First is basic idea. In cluster is aggregation of resources, means to aggregate, to combine the resources. Grid computing, basic idea of segregation of the resources, whereas cloud computing want to consolidate of resources. Running process, in cluster, all process are running on a same software, hardware, and all performing same task. In grid, job is divided into sub job and each is assigned to an ideal CPU so they can run accordingly. In cloud, it depends upon service provisioning, which computer offer a service and provision it to requesting client. Operating system, all are same, nodes on same operating system. They are on a different operating system, they are on a different operating system. Job execution depend upon job scheduling. So job wait until it's assigned a time. When a job will get its time, then it can run or execute. In grid, execution is scalable in a way that moves the execution of job to an ideal processor. And in the cloud, jobs are self-managed. Suitable for app, it's suitable for cascading task, where one task is completely depend upon other task. It's not suitable for cascading task and it is on demand. You give the demand, you pay the money or get the services. Location of nodes, physically located at same location. Grid means the locations are distributed geographically, some on other location, some on other location. And in cloud, location does not matter. Homogeneous or heterogeneous? Cluster is homogeneous, grid is heterogeneous, cloud is heterogeneous. Virtualization in cluster, no. In grid, no. In cloud, virtualization is there. Transparency, yes in cluster, yes in grid, or yes in cloud computing. Security, high in cluster, high also in a grid, or lower than both types in a cloud computing. Next is interoperability, yes in cluster, yes or no in a cloud computing. Applications of cluster, industrial sector, research centers, healthcare centers that offer services on a nationwide. Industrial sector, research center, healthcare, same as a cluster. And applications of cloud, banking, insurance, weather forecasting, space exploration, business, IaaS, PaaS, or SaaS. Implementation, cluster easy to implement, grid difficult to implement, and it's also difficult to implement cloud computing. Management, easiest of cluster, difficult of grid, difficult of cloud. Resource management, centralized in cluster, distributed in grid, both centralized and decentralized in cluster. Internet, no internet access required in cluster. We need internet in grid computing, and we need internet in cloud computing. Next topic is cloud migration. Cloud migration means now we have to transfer the applications, transfer the data or other business components to any cloud computing platform. So cloud migration means I have to migrate to cloud. Most used model is application and data transfer through an on-premises and local data centers to any public cloud. So cloud migration is one of the challenging tasks. We have to face lots of challenges and issue when we are going to migrate from normal server to cloud computing. When we migrate to the cloud, it means we are migrating the documents, applications, components, and data to cloud. I have purchased the cloud on the internet. Now I want to migrate everything to cloud. Now see how it is possible. Now see how it is possible. There are some advantages of migrating your data, components, or any documents to the cloud. First is that flexibility. Flexibility means we does not need to carry the device physically. If you are using the cloud computing, you can access your device, you can access your components, your data anywhere from your cloud. Scalability means it is scalable enough. We can add the number of users, we can increase the number of users, we can decrease the number of users. It is scalable. Agility, it means it provides you the environment where you can do rapid modifications, means fast or continuous modifications according to your updations. Next is productivity. Productivity means it provides remote accessibility. Remotely means once I have uploaded my photos, my even some videos on the Facebook, I do the logout from my phone, and on some other days, after 10 days, after 1 month, again I log into my Facebook ID from someone else's phone. I get all my photos, videos, where it was storing. It means they are all storing over a cloud. Security, it's also provide a good security. We can go for encryption. We can either use some firewalls, secure hardwares and softwares. Process of cloud migration. Now we have to study how can we do the cloud migration. How can I migrate my entire data components into cloud? See how it is possible. First step is plan our migration. Before doing the migration, it's your responsibility to plan how to migrate your data. I want to migrate data only. I want to migrate the components. What I want to migrate, we have to plan it first before implementing the migration. So it's your responsibility to first decide what I have to migrate. Second, I need some skilled people to do the migration. Cloud migration is not done by everyone. I have to search for the trained or skilled people who can do the migration. So it's your responsibility to plan your migration, choose the best strategy for your migration, and make it sure that you have a skilled persons, your trained employees who can do the migration in very easiest manner. Next, select our cloud environment. Again, it's a very important step. You have to choose very wisely which cloud environment you want to choose. Most popular, you want to go for a Google Cloud platform. You want to select the Microsoft Azure. You want to go for Amazon Web Services. It means now it's your responsibility which cloud environment you want to choose. Either you can go for a private cloud, multi-cloud, hybrid cloud, public cloud. It's your choice. So first, plan your migration strategy. Second, select your cloud environment. Third, migrate our data and app. Now, once we have planned, means strategy is final. I have a skilled employees. I have already choose the cloud environment. Second is migrate your data. Now, there is no any other option. Everything is decided. Now, your task is to migrate our data. So you can migrate either in a private network or public internet. You can use it even a transfer in a online mode. So you can even migrate in a online mode or in a offline mode. Certify post move success. Our migration, our work is not complete until we can show any return over the investment in our migration. It means if you do the migration, you see there is no any benefit of using cloud. This is not fair. You will be satisfied after migrating your data into cloud. So when you want to migrate your data into cloud, you have to follow some basic steps. First, plan your migration strategy. Second, select the best environment according to your requirement. Third, migrate your data and apps into the cloud. And fourth is be satisfied with your migration. Next, we have a 7-step model of migration into cloud. Migrating is not an easy task. So if you want to migrate, you have to follow 7-step model. Next, we have 7-step model of migrating into cloud. Now we have to follow 7 steps if I want to migrate my data to cloud. First is assessment. Very, very important. First, you have to do the assessment. You have to assess the issues that you have to face regarding your migration. What problems arises during coding? What problem arises during design, during architecture? You have to do the assessment regarding the tools, regarding the functionality, regarding the test cases. So I have already told you of all of you, migration is not an easy task. So when we migrate the data from the server to the cloud computing, we have to first assess. You have to make some assessment. What cost I have to pay, how much I have to pay to the vendor, what challenges I have to face, what are the various challenges, issues, and strategies we have to face and follow, all should be decided in assessment phase. Next is isolate. Isolate means you have to make the difference between the applications and architectures that is on a server or that is on a cloud. It means the data that is on your simple server or on your computer server is isolated. Isolated means hides from the data or application that is on your cloud computing. So make the difference or hide the data on the cloud computing from the data on a server. Next is map. A mapping construct is generated to separate the components that should reside in captive data centers from ones that will go into cloud. As I have already told you, you have to make a difference between your data in the data centers or your data into your cloud. As we all know that, let us suppose that still I have some photos on the Facebook which is not physically present in my mobile phone. It means there is a difference. Re-architect. It is likely that you have to re-architect some components. This can affect the functionality of application and some of these might be lost. Yes, it's completely true. When we are migrating the data into the cloud, when we are re-architecting, when we are re-architecture it, there will be a chances that functionality of some of the applications will lost. So it is one of the problem that we have to face. Fifth is augment. It means you have to upgrade it. Once we have forward the data from server to cloud computing, you just need to do the upgrading. Next is test. Now everything is done. We have uploaded or migrated the data from the server to cloud computing. Now your task is to test it. To check its validations, you just need to test it. Either it is according to the requirement or it is working well. Next is optimize. The test result from the last step can be mixed or so require iteration and optimization. It means if the test result is according to your requirement or if you are satisfied, then go ahead. But if you feel some problems, some failures, some issues in the test, you have to optimize it. Means you have to refine it, work again on it. It may take several optimizing iteration. You know the iteration means work on it in a continuously manner until we get the best result. It is the best to iterate through this 7-step models, as this will ensure the migrating to the robust and comprehensive way. So by following all these 7 steps, you can migrate your data to the cloud in a very robust and comprehensive manner. क्लास में डिस्कस करेंगे broad approaches to migrating into cloud. When we are migrating the data into cloud, what strategies, what rules we have to follow? We have 6 R's of migration: rehosting, replatforming, refactoring, repurchasing, retiring, and revisiting. They are called the 6 R's of migration. Now see one by one. Rehosting. Now we are doing migration. It means we need rehosting. We are migrating the data from the server to cloud. It means we need to lift and shift it. It holds our applications and then drop it into new hosting platform without changing the architecture and code of the app. It is general way of enterprise unfamiliar with cloud computing who profit from deployment speed. It means when we are forwarding or when we are migrating the data from the server to cloud computing, it does not make any changes to my server. Once the data is migrated to cloud, server will look like same. So rehosting, and which is also known as lift and shift, it means we just need to do what? We just need to migrate the data from server to cloud. Nothing will happen other. So it will not affect the architecture of server. It will not affect the working of server. We just need to copy the data from server and paste it back into the cloud. Next is replatforming. It is also known as lift, tinker, and shift, making some cloud optimization without modifying our app core architecture. So it means replatforming. You just need to replatform it. Lift, tinker, and shift. It means you when you are doing migration, it means we are just replatforming. We are not updating it. We are not editing it. We just need to replatforming. Refactoring. When we are migrating the data from server to cloud computing or to cloud, we just need to refactor the server style. Means we just need to rebuild the applications because now the previous data is completely sent or completely forwarded or successfully pasted into the cloud. We just need to refactor the server after doing the migration. Next is repurchasing. Repurchasing means now we have to replace the previous architecture with new architecture. It is only possible after purchasing. Purchasing means once your migration is done, you have to repurchase the new applications. It may be either based on a software as a service, platform as a service, or infrastructure as a service. Fifth R is retiring. If you feel some of the applications are not working according to the requirement, you just need to retire it. Retire means you just need to even either you can do the uninstall it, or even you can turn off it. It means so that they are not consuming the space on your server. You just need to retire it. Last is revisiting. Revisiting, maybe all or some of our application must reside in the house. For example, applications that have unique sensitivity or handle internal processes to an enterprise. Don't be scared for revisiting cloud computing, and at any later date. We must migrate only what make effects to business. So revisiting means once you migrate your data from server to cloud computing, you can revisit to the cloud computing anytime, or either you can revisit to your server. So these are the 6 R's of cloud computing that you have to follow when you are migrating your data to cloud computing. Thank you so much, class.